Hi, this is Pre-Algebra, lesson 4-4, solve percent change and percent error problems. In this lesson, you'll be able to solve problems involving percent change and percent error. Let's look at explain it. Nadia lives in the town of Preston. Quinn lives in the town of Elmridge. Nadia and Quinn each claim that her respective town's population is growing more rapidly. So Nadia is Preston. Quinn is Elmridge. And they're claiming that their town is growing more rapidly than the other. Let's look at the population. Elmridge, population last year, 1,870. Population this year, 1,926. Preston, population last year, 5,589. Population this year, 5,702. So who's right? Well, we're gonna write an argument to support both sides. Let's suppose that Nadia is correct. Okay. How can Preston increase more? Let's both subtract the number of population so that we can see how many people actually have increased. Okay, so 5,702 minus 5,589 was 113, right? Yeah, 113. What about Elmridge? 1,926 minus 1,870 is gonna be 56. Yeah, so it increased by 56 people. So Nadia could be right if we're just counting the numbers that of people who have increased in the population, right? So we can say Preston's population is growing more rapidly because 5,702 minus 5,589 is 113, right? And 1,926 minus 1,870 is 56. And 113 is greater than 56. So, and let's label which one is which. That's Preston. And this is Elmridge. So, and that's Preston, and this is Elmridge. Okay, so Nadia is right. What about an argument to support Quinn? Why might she argue that Elmridge's population is growing more rapidly? Obviously, you know, the number of people increasing is greater in Preston. How can Elmridge be increasing more rapidly? Well, let's look at the percentage. Let's compare the percentage. And if the percentage tells them that compared to last year, we grew this many percent, it might be different, right? So let's look at Preston's percentage. Preston grew. So the part here is going to be increasing because we want to know how much it grew. So we started from the whole 5,589 and it became 5,702 this year. And percentage wise, that is 1.03, right? Wait, 1.02, sorry. 1.02 if you divide both numbers, and percentage wise, that's 102%. Okay, and then average is going to be growing from 1,870 to 1,926. If you divide both numbers, you get 1.03, and that's percentage-wise 103%. So whose population grew more in percentage? Average. They started with less people, but they grew a little bit more. So 102 is less than 103. So Quinn is right. So whose reasoning is more logical? What do you think? Which one is more logical? Is it fair to just compare how many people have increased? Or is it more fair to compare the percentage of increase? Well, you can argue for both, but please explain with a good reasoning. I will say that Quinn's argument makes more sense because she compared the proportions using a ratio. Okay, and why this value would give better measure of change than just the change in population. It would give better measure of change than just the change in population. Okay. Focus on math practices. Suppose Preston's population is expected to grow 3% next year. Nadia says that this means the population will increase by 300 people. Is Nadia's reasoning correct? Explain. So what's 3% of Preston's population for next year? Because this year, Preston's population is 5,702, right? So this year, 5,702. And so 3% of 57, that's 7. 5,702 is 0.03 times 5,702. Okay. Which is how many? 171 people. It is not 300 because 300 is 3% of a 10,000 people. Wait, I put an extra 0. A 10,000 people. 3% of 5,702 is 171. Okay. So no. Essential question. How is finding percent error similar to finding percent change is what we're going to think about in this lesson. Let's look at example 1. 5% increase. We have a vocabulary word, percent change. The percent change describes how much a quantity has changed relative to its original amount, using percentage, of course. The percent change can be an increase or decrease. What is the percent change of the alligator's length from last year to this year? Last year, he was 32 inches. This year, he is 38 inches. So what's the percent change? Not how many inches did he grow, what's the percent change? What representation can show the change in the alligator's length? Ratios. Ratios, of course. So step 1, you're going to draw a bar diagram to represent the percent change from last year to this year. And you don't know the percent change. That's what you're trying to get. But you know it grew 6 inches because 38 minus 32 is 6 inches. We know 6 inches is how many percent of 32 is what we're going to figure out. Again, use the part equation. Part is equal to percent times whole. Part is the change in length, which is 6 inches. And then percent change is what we're trying to figure out. So leave it as a variable. Original length is 32 inches. Okay, that's from last year. And so 6 is how much percent of 32 is our equation. 6 divided by 32 is 0.1875. Change that to a percent by multiplying by 100. And that's 18.75%. So 6 inches is 18.75% of 32. And the alligator grew about 18.75%. Okay, so let's try this question. Come back when you're ready for answers. So what will be the length of the alligator next year if its length changes by the same percent as it changed this year? Right? So this year is 38 inches. And if it changes the same percentage, we want to know the total change in length in inches. So that's 100%. And we're going to have, we're going to try to figure out what's 18.75% of 38 inches. So use the percent, the part equation, percent change times the length of this year, which is 38, is equal to change in length. So you multiply that out, but the change in length would be 7.125. Okay, so 38 plus 7.125 is 45.125. So next year, the length of the alligator will be 45.125 inches long. So the change in length is 7.125 inches. And the total inch of the alligator's length would be 45.125 inches long. Okay, why is the increase in the alligator's length different from year to year, even though the percent change stayed the same? So because 18.75% of 32 is obviously different than 18.75% of 38, because 100% what changes, right? 100% of last year is 32. 100% of this year is 38. So respective to the 100%, the whole, our part changes in respect to the whole. Let's write that in words. Okay, the percent change is based on a different length every year. And so the length of the alligator was greater this year than last year. So the same percent change of that length will be greater than last year. will do. All right, ready for example 2? Example 2, find percent decrease. Last year, a website had 40,000 visitors, and this year it had 37,000 visitors. What is the percent change in the number of visitors to the website from last year to this year? So now we're going to find a percent of decrease. To find a decrease, we're still going to use the part equation, right? And but we need to identify what's the whole and what's the change, right? The percent change is the percent decrease because the number of visitors decreased. So the change in attendance is 3,000 when you subtract 40,000 minus 37,000, right? So we want to know what 3,000 is, what percent 3,000 is for 40,000 visitors, because that's where we started. So change in number of visitors is 3,000. You don't have to put negative. We know that it's a percent decrease, okay? Percent change is what we're trying to get. Number of visitors last year was 40,000. And so 3,000 divided by 40,000 would be 0.075. The percent would be 7.5%. So it decreased by 7.5%, or you can represent it as a negative 7.5%. Okay. Example 3, finding percent error. Sean estimated that the attendance at college lacrosse game was 3,000, and actual attendance was 3,296. What is the percent error of Sean's estimate? Round to the nearest whole percent. So what's the percent error? That's a vocab word. Percent error describes the accuracy of a measured or estimated value compared to an actual value. It is always a positive percent. Percent error could be, you have an estimate. We solve problems and predict by math, using math, but then actually in real life, it doesn't always follow exactly as the calculations do. So that is called the percent error. What is a percent error, right? We're going to use the absolute value because absolute value represents the distance from something, right? So we're going to use absolute value to find a positive difference between the estimated and actual attendance, because percent error is always a positive number, positive percent. Okay, so and then we're going to use percent equation to find the percent error. So 3,000 was last year, right? 3,000 was the estimation, and then you subtract the actual attendance, and that's the difference, 296. And if you make that positive because it's an absolute value, 296 is the difference, right? So that's the difference in attendance, and that's what we're gonna figure out as a percent error. Difference in attendance is how much distance it's away from the actual number, right? From the actual number versus the estimated value. So difference in attendance is equal to percent error times actual attendance. So actual attendance here is going to be the whole, right? And difference in attendance is going to be the part. So what is the part in percentage is what the question is actually asking. 296 is equal to P times 3,296. So in order to solve for P, divide both sides by 3,296, and you get 0.0898. What is that in percentage? You multiply that by 100, and that's 8.98%, which is about 9%. The percent error is about 9%. Okay, so percent error, basically you need to find the difference and then find the percent of that difference in comparison to the whole. Okay, let's look at the try question. We have another percent error problem. see if you can do it by yourself. If not, that's fine, but come back when you're ready for answers. The specification for the length of a bolt is 4.75. That means, when you buy this bolt, it says it's going to be 4.75 inches, but in real life, it's going to be a little bit different. All the bolts are going to be a little bit different because the world is not perfect, of course. Okay, even though you make bolts in a factory, the factory will print it out slightly different bolts. It looks the same in our eyes, but it's slightly different every time. Okay, it is 4.75. It is close to 4.75, but we want to know the percent error. This bolt is actually 4.769 inches. So we're going to find the difference and find what that inch is from the whole, what that inch is represented as a percentage from the whole. Okay, 4.75 minus 4.769 absolute value is the difference. Okay, and that's going to be positive number because we want a positive percent error. Okay, and if you subtract that, you're gonna get 0.019. Negative 0.019, absolute value is positive 0.019. And what is our whole? You're gonna use this equation, difference in attendance, 0.019 is equal to percent error. That's what we're trying to get, times the actual bolt size, 4.769. Okay, that's our whole. And then you divide both sides by 4.769 to get P. So 0.019 divided by 4.769 is 0.03984 ... So multiply that by 100, it's going to be 3.984 ... And so percent change is about, 0.39, not 3. Is that right? 0.0, yeah, that's 3. Sorry, I'm checking my math. 0.019 divided by 4.769 is actually 0.00. Because, yeah, it shouldn't be that great. 3% is a big percent for a bolt. Yeah. So 0.3984%. So about, when you round that up, it's going to be about 0.4% or 0. Let's do 0.4%, about 0.4%. Okay, so first you find the difference, find the absolute value of the difference, and divide that by the actual bolt, or the whole number, and then the whole percent, or the number that represents the whole. There you go. And that's going to be your decimal of the percentage. And so you have to multiply that by 100 to get the actual percentage. All right, so that was lesson 4. You solve percent changes and percent error problems. Percent change and percent error problems are kinds of percent problems. So you can expect to see them whenever you see percent problems. Okay, so you can use the percent equation to solve them. The amount of change could also represent the part. And the percentage change times the original amount would represent the whole. Okay, that was lesson 4. We'll continue with the next lesson in the next video. Bye.